Welcome back to the MacAdmins Campfire sessions. Let's continue with the second half for today. I'd like to introduce our second speaker, Seb, and his presentation, create a build and deployment pipeline for your iOS apps with Amazon EC2 Mac Instance. Hello, Seb.
Hey, good afternoon. Thanks for having me. I'm Sebastien Stormacq. I'm a principal developer advocate at AWS, and I'm just fighting with teams that decide to not share my screen anymore 1 minute before going live. So I don't know what's happening. Let me try to recover that very quickly. You can see me, yes?
We can see your slides now. Yep, it looks like you're ready to go.
And you can see the slides too. The full screen or just the slide? No, just the slides. Perfect.
Just the slides right now. Yep.
Perfect. Great. So I said, I'm Seb Stormacq. I'm a principal developer advocate for Amazon Web Services. I'm originally from Belgium, living in France. You might have detected a slight touch of French accent when I'm speaking, no, a huge touch of French accent. In this session, I'm going to show you how you can automate a build process on macOS, just using the command line, and how you can integrate that build process into a larger orchestration, usually known as a continuous integration, continuous deployment, and how you can do that on the cloud using Mac machine running on AWS. So part of this presentation is a bit oriented towards AWS. I'll try to be very clear and explain the concepts and not to spend too much time on AWS specific details and spend more time on the macOS generic stuff, because the CI/CD, the automation of the build, it's something that you can do actually on any system, even systems that you have on-prem. So continuous integration. If you're not a developer, what is continuous integration? Continuous integration is the idea of building your application every time there is a change in the source code. So every time one of the developers commits a change to the source code repository, it triggers a build, an assembly of the application, and running the tests, integration tests, unit tests, GUI tests, whatever, and maybe even publish, that's the second part, continuous deployment, publish the application on the store. And you can automate a big part of that on macOS using just a command line integration. The advantage of continuous integration, it allows to catch error much more quickly than, if you make a change and the tests are broken, you have only one change to look at to understand where the error is coming from. If you're doing test every 6 months, if you integrate software code level change every 6 months, it's much harder to find the root cause of one specific problem. The challenge is to integrate Macs into that, because a typical CI/CD chain is built around an orchestrator, some kind of workflow machine that will organize the build, the test, and collect the result and provide dashboard. And these are typically running on Windows or Linux. So how can one of these systems delegate build command to actually do the compilation and the test on macOS? And most of the time, you cannot. It's quite difficult to do, because on macOS, we are used to use Xcode to develop, which is a super nice application at graphical user interface level. But there is little documentation about how to automate your process. What our customers are doing is they are buying a couple of Mac Mini, put that in a closet on a shelf, and this is an actual picture coming from one of our customers. And they manually manage that. So they have one person dedicated to rebuild this machine, reinstall, patch, update, integrate this machine with their Linux-based orchestrator to run the builds from distance on this machine. These are headless, so they manage it through SSH only. And it takes a lot of time. And every time there is a new version, or if you need to compile for different version, you need to test on different version, you need to segregate these machines. You need to recreate the whole environment from scratch when you reinstall a machine. So it's time consuming, error prone, and not super efficient. So if you want to do CI/CD for iOS, or by the way, tvOS, watchOS, or any other Apple-related operating system, the first challenge is to provision the hardware. I just explained the pain point of using physical hardware to do so. Second challenge is to automate the build process. I explain you the challenges as well. Usually you have Xcode, you know how to use Xcode, but how can you automate that from the command line? If you have an orchestrator, and even an orchestrator in the cloud on AWS with a service called a Code Pipeline or Code Build that allows to run builds in the cloud, but I guess other clouds have similar systems. How do you integrate a macOS machine part of that workflow? That's the third challenge we are going to talk about today. And the last one is really specific for AWS customer. If you're running your workflow, your CI/CD pipeline in the AWS cloud, how do you integrate with other services? Maybe you want to upload your build result, your EPA file or your zip file to Amazon S3 for archiving. Maybe you want to use Secret Manager to distribute your certificates, your private key to sign your code on the build machine. How to do that securely in the AWS cloud. So that's the fourth challenge we are going to try to address during the rest of this talk. So let's start with challenge number one. On Amazon, since roughly 1 year now, you have the ability to start a macOS machine on the compute service from Amazon called EC2. So EC2 is one of the oldest AWS service in the cloud. It allows you to create virtual machines with Linux or with Windows. Since 1 year, you can have macOS instance as well. It's not a virtual machine. It's a real Mac Mini connected in one of our servers, connected to our network, which is able to integrate with all the other networking and security and other services that you maybe know and love from AWS. So for those of you knowing AWS, you can connect these macOS instance into a network. Now that's a VPC. You can have security groups or kind of network configuration that define what type of traffic can enter into that machine. You can make snapshots of the boot volume at any time, and you can create templates to restart another machine based on these snapshots. So if you spend 2 hours to configure all your dependencies, you can snapshot that and restart as many other macOS instance as you want using the snapshot that you just created. So you don't need to reinstall everything from scratch again. So tons of integration with the rest of AWS, just like if it is a Linux or a Windows virtual machine. The only huge difference, it's not a virtual machine. It's really a Mac Mini, and this is a picture taken from our hardware inside our data center. So it's a rack full of one U computer, and into that we plugged regular Mac Minis. And the magic of the virtualization or the integration with the rest of the service is made by hardware designed by AWS. It's called Nitro. Nitro is the virtualization system from AWS. So basically we have a connector in the Thunderbolt port of the Mac Mini that is connected to that Nitro card, and that Nitro card does the magic to connect the Mac Mini to the network and to make it available through the AWS console, the AWS SDK, the AWS command line. Dedicated hardware, it's not new. It's something that exists on AWS as well. And so for macOS, the first thing you need to do when you want to start an EC2 Mac instance, it's to allocate a hardware host for you. So basically you're telling AWS, hey, I want to book that Mac Mini specifically for me, and it will be dedicated to my own usage. And on that, you can start macOS. So there is no virtual machine. It's one OS per physical host, and you're the only one using that physical host. So you need to acquire that physical host and reserve it for a period of time. The way to do that by the command line, you can do that on the console as well, but it's more fancy to show the command line. At least you can automate that with the command line. AWS EC2 allocate host. The name of the instance type is called Mac1 Metal. You give the availability zone, so roughly the data center where you want to start it. and the quantity, and you receive a host ID result for you. And then the second step is to actually start macOS, so EC2 run instance, just like starting a virtual machine. Again, it's not a virtual machine here, it's the real macOS running on bare metal. So you give the name of the instance type, Mac1 metal, an SSH key you want to connect, and your host ID that you just received from the previous one. If you want to start with a specific AMI, so an AMI, it's a pre-installed operating system image. It might be your image with your dependencies and your software, or it might be one of the image provided by Amazon, and we do provide picture, Monterey, and Catalina, I think, image. Or we used to have Catalina. I'm pretty sure we still have Catalina in the list there. And after a while, the machine is started. We inject your SSH public key there. Depending on the operating system, you have one or the other installed, and then you can use your laptop to make a SSH connection over TCP/22 to authenticate, and you have command line access to your Mac. If you want to have graphical user interface, you need to start a VNC server, so ARDP, I think in terms of Apple. You might need to resize your EBS volume. You might need to change the resolution of the screen or things like that. It's all documented in our documentation. In a long version of this presentation, I'm showing you all the commands to do that, but it's pretty well documented on the EC2 Mac page. So usually I try to not start any graphical user interface and do all my installation, Xcode, and various libraries through command line. All of that is documented on my GitHub, and I will share you the GitHub at the end of this talk. Yeah, let's talk about things that are maybe more difficult to hear. There is a price for that, of course, and the price is roughly in US East, so on Northern Virginia data center is roughly $1 per hour, and it's per hour where you reserve the dedicated instance for you, not hour where the instance is running. And that's a bit different than from Linux or Windows on AWS. Typically, you pay by the second of the virtual machines. Here, there is no virtual machine. You have a host allocated to you, dedicated to you. So you pay $1 per hour of this host being allocated to you. Even if you stop it, you will be charged. There is a minimum of 24 hours. That's an Apple license, I would say restriction, or an Apple license requirement to lease the host for minimum periods of 24 hours. After that, it's a billing per second as usual. Of course, you can have different saving plans and save money on the price I just announced. The one I just announced is on demand, but if you have a regular usage on the long term of these machines, you can buy saving plans that will reduce your price up to 66%. So that addresses the first challenge. How can I provision hardware? You do not need to provision hardware anymore. You can get macOS and Mac Mini from AWS as EC2 instance. The second challenge has nothing to do with AWS. It's how to automate a build. So you need to build, you need to test, you need to sign, you need to archive, you need to upload your archive to App Store Connect if you want to distribute them on test flight, for example. And I will show you all that. I have a 7-minute demo at the end that shows you all that. So quickly, building from the command line, it's Xcode build. Code signing is a bit more difficult. So this is what works for me, and I spend hours trying to configure that. And again, there is almost no documentation or partial documentation on the web, or when you find something, it's like 3 years old, it's not working anymore. So I spend a significant amount of time to get this working. And what works for me is there is no login keychain. So now, let me rewind a bit. Xcode command line is going to find your signing certificate inside a keychain. When there is a graphical user interface, there is a login keychain. Here, there is no graphical user interface, so there is no login keychain for the user. So what works for me is to create a dedicated keychain and inject my certificate and signing key into that keychain. But of course, the keys and the certificate you're injecting there needs to be validated, need to be recognized. So you also need to import Apple root certificates. There are 2 or 3 Apple Worldwide Developer Relation certificates and the Apple root certificates that you need to import. And to import that, you need to import that in the system keychain. If you import them in the dedicated keychain, it does not work. And then when you import them, you need to configure the keychain to tell what are the applications that are allowed to read that key. So there is a couple of massage on the configuration side to correctly configure the access permission. Creating a keychain, it's very easy. Security, create keychain. You can give a password, you give your keychain a name. Then you have to unlock the keychain. That's something that happens automatically when there is a graphical user interface session. On SSH, you need to do that by yourself. So you type security unlock keychain with the password and the name. You can list all the keychain, and there is a settings as well. I don't remember the command there to tell macOS to not relock the keychain after a while so that the keychain stays unlocked. Importing, assuming that you have a file with your certificate. I'll show you later how you can get that. But importing, security import, you give the name of the certificate, the password, the name of the keychain, and the -T options there allows you to tell the authorization. What are the applications that are allowed to read that keychain? And here it's Xcode build and code sign that are authorized to read that keychain. How do you get your certificate on that macOS machine in the cloud? The way it works for me, I export them from my laptop from using the keychain graphical user interface. I export that as a P12 file, and then I store that in one of the AWS services that I'm going to talk in section 4. It's Secret Manager. Importing the root certificate, there is only one root certificate to import. It's publicly available because it's a public certificate. It's Apple www.cag3. The URL is there, and you import that into the system keychain. And that's a super important point. If you do not insert that in the system keychain, it's not working, and you're going to have additional white hair like me, because you are going to spend night trying to understand why your keys is not recognized. So your keys in a dedicated keychain that you create just for the build, the Apple root certificate in the system keychain. On the keychain that you just created, the dedicated one, there is a couple of additional configuration to authorize Apple and code sign and different tools to access it. It's called set key partition list, security set key partition list, giving your keychain password and keychain name. There is another binary file that you need to have on your laptop for Xcode to build. It's called the profile, the mobile provisioning profile that associates the certificate with your team ID and your device ID. You generate them on the Apple developer portal. Once you have them, you have to locate them with a very specific name, which is their UUID, in a very specific directory. It's in library mobile device provisioning. So the one part of the setup of your machine is to get this file there, compute the UUID, and copy the file with the correct name under the correct directory to allow the build to succeed. If you're developing on AWS, you're most probably using Amplify, so you will need to integrate in your build command to retrieve the configuration of your Amplify project. I'm not going to spend too much time on that. You will need to increase your build number. That's part of the build sequence as well. There are different ways to do that. I like to use the date command just to link back to what Bill said before. And I'm using year, month, date, hour, minute, second as a build number. So assuming that I'm doing less than 1 build per second, I will have an increasing number, a number that will increase. And that number carries some metadata as well, because just by looking at the number, I know if it is a recent build or an old build. Of course, if you are producing more than 1 build per second, you need to have a different strategy there. But I'm generating that in my build script and then use the PL util to replace that value in the info.plist of the application. And then the last step of your build is to upload to App Store Connect. I will show you that in the demo, but you can do that from the command line as well, as long as you know the Apple ID and the Apple secret, so the password of your Apple developer account. You can build the EPA file and upload and start the distribution automatically to your test flight user, not to the live App Store, of course. It requires the validation step from Apple, but at least for your beta tester, if you distribute the application with test flight, they will receive the update automatically with that. And that is supposed to solve our second pain point. The second pain point was to automate the build process. The third pain point our customer tell us is how to integrate a Mac machine with a build orchestrator. Many are using Jenkins or GitHub Actions. On AWS, there is something called code pipeline and code build. If you look at that schema, you have the developer on the bottom left side, using Xcode, pushing code to GitHub. And then in the cloud, you can configure an AWS service called code build, which is aimed at building your application. And to do that, it runs a Linux Docker container. And that's great for Linux application or anything running like Node.js or Python or something. But if you want to build a tvOS, iOS, macOS application, you need to delegate the build to the macOS EC2 instance that you have just installed. So you need some kind of two-way communication between code build with containers on one side and your macOS machine. And there are multiple ways to do that, from a simple SSH from code build to the Mac instance, not very secure, not scalable. You can use specific AWS service such as System Agent, System Manager. The agent is pre-installed on macOS. For my own needs, I choose, but that's my decision, to use a command-based system based on queues. So I'm using the queue service from AWS called Simple Queue Service, and my build from code build just post message in a queue. Then on the macOS instance, I have a small agent which is looking at the queue, taking the message, and executing the commands in the message. And it collects the log file of the output of that command and send everything back in a response queue. And the build step is waiting for the response to come and then send the next message to the machine that can pick up the message. So I'm using that queue, double queue mechanism, as a command queue and a response queue, to asynchronously talk with the machine and send order to the machine. I build the SQS producer, so the application that generates the message to the queue, and the build agent, so the SQS reader, using Swift. It's a command line application, and you can find that on my GitHub there. Swift build agent SQS. It's a tiny command line written in Swift. And the fourth challenge was to integrate other AWS services. And because I assume you are not all fluent with AWS, I'm not going to bother you too much with that part. But maybe just one thing is this thing about your secrets. How can you retrieve your build secrets? You know, you need the Apple ID password if you want to connect to App Store Connect, or you need your certificate and your keys to import into the keychain, as I showed before. There is a service designed to securely store your secrets on AWS. It's called AWS Secrets Manager. And you can use Secrets Manager to store your key, store your password, store your certificate in the safety environment, in the safe environment provided by Secret Manager. And then at runtime, when you prepare your machine, your script pulls the secret out of Secret Manager, provided the machine has the correct authorization to do so, and inject the secrets into the keychain. What time is it? Okay, I just have the time to show you the demo. It's a 7-minute demo. It's pre-recorded, so it will not crash. And I would like to show you that process end-to-end, how it works end-to-end. So for that demo, I'm going to use a demo application that I build and that we use as a tutorial on AWS called Build an iOS application using AWS Amplify. I'm not going to explain you how this application works. It's a very basic hello world type of application. The source code is available on my GitHub as well. Amplify iOS getting started. There is the source code of the application, and inside the code repository, there is all the build script. So all the scripts to provision the machine, to install Xcode, to import the secrets, to build, to test, to upload to the App Store Connect. Everything I talk about, it's there in that code sub directory. The application is distributed with a test flight. So this is my phone, the screen of my phone, and the application is a note-taking application with a picture, title, and a text for a note. And you see there is this ugly green background that the developer chose to use for whatever reason. And we are going to remove that green background and put a white background instead. We are going to make that change, push the change to GitHub, and observe the full build starting up to the delivery of the application in test flight. So I switch to Xcode. I identify the line of code responsible for that color green. I see in the preview that indeed it's the right line of code. In real life, I would probably test it locally, build locally, run my unit test locally before committing my code to GitHub, but it's not real life here. It's just a demo. So I directly go to the source control part of Xcode. I type a commit message because my grandma always told me, put a commit message on every single of your commits. So my commit message is remove green background. I commit to Git locally, and then I push the change to GitHub. Now that I have the change on GitHub, let's switch to Git and refresh that page. And you will see that I have a change from 24 seconds ago. So the change arrived on Git. From GitHub, it will trigger a build in AWS Code Build. I have a project there for my macOS build. If I refresh the project in the AWS console, I can see that the status change, it's in progress. So the change has been detected and it triggers a build sequence. Remember, code builds use Docker container with Linux, so the build doesn't really happen in that service. That service, I can see the history of my builds there. That service use a very simple script I provide as part of my project to send the actual build command to a macOS application running in the cloud as an EC2 instance. And I can observe in the code build console the different steps and the output of my build. So what are the different options? There is an install, a pre-build, and a build and a post-build phase. And for each of these phases, I'm using the command line tool I wrote to post a message in the queue, and the message contains the name of the script to execute. So a list of instructions to execute on the other side. And the SQS producer tool has an equivalent running on the macOS machine in my fleet that is pulling message from the queue and executing the build order that it receives. And whenever there is an output on the macOS, it sends the output back over SQS. So code build knows the output and the status if the build pass or fail, for example. So if I go to my EC2 console, I can see I have two Mac running there. I go to the EC2 instance detail to grab the IP address, the public IP address of my Mac running in the cloud. So I take a terminal on my laptop and I SSH connect as user EC2 user on that Mac. And I am welcomed by that nice graphical prompt. And I can observe the build as it is going. All the logs are in a file. I can tail that file, and I can see that, yes, indeed, there is some activity there. There is a build sequence. And at each end of the sequence, I receive the log file there. I can see the result, for example, the installation of Cocoa Pods plugin. I can see the result directly there. So the whole process there on an x86 Mac takes roughly 10 minutes, 12 minutes. So I pause the video a bit, but eventually the build status will appear and hopefully as success. And yes, for me, it's a success. At the end of the build, I'm pushing the build to App Store Connect. So if I connect to App Store Connect, I can see I have a new build there currently processing. So they receive a new binary from me. And they are running a couple of pre-check on that binary before the binary will eventually change to status and become ready to submit if I want to submit that for approval to publish it on the App Store. But because I'm using TestFlight as well to distribute the binary to my test user, as soon as the binary is ready to submit, my TestFlight user will receive an email saying, hey, there is a new version, a new build of the app. And if I take my phone back and I see there is a new version of Getting Started that is available in TestFlight. So this is a TestFlight app, and I can open. Yes, my phone is in Spanish because I'm learning Spanish as well, but. I can open the new version of this app directly from TestFlight. And if I do that, the Note app opens and the notes are loading and there is no more green background. So my change arrive almost magically on my phone through TestFlight and an automated build. So that's an end-to-end demo. I start with the app with the bug to fix running on my local laptop. I made the code change, push that to GitHub. GitHub starts a code build process in the cloud. That code build process sends message over a queue to a macOS instance running on EC2, running in the cloud as well. It goes through the entire build, report the status back to code build, and also push the binary to App Store Connect and distribute it automatically to through TestFlight. So continuous integration on iOS, yes, it's possible. It requires a bit of setup. It requires a communication mechanism between your build orchestrator and your macOS worker machine. Once again, there are multiple options. I choose, but that's my design decision to use a queue-based system. Other systems might work as well. You can. It's a four-step process. First, you learn to automate your build on macOS. So even if you don't have an EC2 instance running in the cloud, try to close Xcode and have a build process running on your laptop. It will mostly work because Xcode is doing a lot of magic behind the scene to get your certificate and signing key correctly set up in your keychain. So if it works in Xcode, it will work on command line from your laptop as well. If you need details instruction there about how to build, to create a machine on EC2 and how to build, go to my GitHub repo. You have all the source code for this demo available there. Second thing you have to think about is how to integrate that build with your build pipeline. Maybe you are using Jenkins or GitHub Action or Code Build like me. How do you make these two communicate? I choose to use SQS and queues because it's an AWS demo, but you can choose any other way that works for you. And then just get rid of your laptop and get a Mac in the cloud. You can start your EC2 instance today. And the fourth step, yeah, but there is no fourth step. It's just as easy as 1, 2, 3. And once you have that setup in place, your imagination is the limit. You can really create scripts that are mind-blowing, that will automate all the tasks you used to do manually. So now it's your turn. You still have the afternoon if you're watching from the US. You can go and build in the cloud. Thank you for having watched this demo and listened to me. I have a very, very short, totally anonymous survey if you want to take 15 seconds to fill in that survey. There is only 3 questions. And if you apply for the survey, you can receive an AWS service credit code of $25 that you can redeem on your AWS account. So you can try that. You can try an EC2 Mac instance. Remember, it's for 24 hours minimum. So the $25 will cover that for 1 day. Don't forget to release the dedicated host after 24 hours. Because otherwise the charge will increase on your account, and I don't want you to have any bad surprise because of me. Any questions? I'm available for you to answer your questions.
Thank you very much, Seb. That was a very awesome presentation. Very informative. I learned a lot. We don't currently have any questions for you right now, but we will say and just prompt the crowd if there's anyone watching that has a question at the moment. Feel free to type that into the Q&A. We're going to leave up, maybe we'll put up that survey link again real quick and let people take a look at that while we wait for a question. And if we don't have any questions here in a couple of minutes, then we'll
you can ask your question on PSU Mac as well. I'm having a look on Slack as we are talking.
Awesome. Fantastic. Thank you. Yes. The PSU Mac Slack channel is a great place to talk about today's presentations and to follow up with our presenters if you have any specific questions. We have the survey slide posted in the PSU Mac Slack now too, yep. So feel free to go.
Thank you.
Feedback there. Okay. All right, great. Well, I think you've done a fantastic job, and everyone is well informed. And okay, we have one question: is the demo available anywhere?
The source code of the demo is available on my GitHub. I can go back, or you go to github.com/sebsto and you will find it very easily. It's one of the top repository there. It's just a source code with full instruction, but there is no ready-to-use demo. Click and deploy. You still need to work a bit. There is a question on Slack as well. Do you have any insight on the availability of M1 Mac in AWS? I was expecting someone to ask that question, so thank you for asking that one. We have pre-announced availability of M1 Macs at reInvent. That's our customer developer conference back in November last year. It's in preview right now, so you can apply to the preview, and it should not be long. let me. I cannot give you a specific date because they keep pushing it by 1 week, but we are just around the corner.
So maybe next week. All right. Okay, fantastic. Well, Seb, I appreciate it. And thank you for taking the time to deliver us today's second session.
My pleasure.